Okay, let's revisit resistance, and specifically we're going to talk about the CCA, the common carotid artery. So first of all, let's have a look up in the left-hand side here. This is the ICA, the internal carotid artery, remembering that it feeds our brain. So it is a low resistance waveform. It has a broader systolic peak. It has lots of end diastolic flow. It's monophasic, meaning that it is above the baseline during all parts of the cardiac cycle, and it has low pulsatility, a smaller difference between the peak systolic and end diastolic velocity. Let's bring our eyes over to the right-hand side of the screen, the ECA, the external carotid artery, remembering that it feeds structures of our face, such as our tongue, cheeks, mandible, etc. So the ECA feeds a higher resistance or a higher resistant bed, arterial bed. Our face does not need to have blood supply at all parts of the cardiac cycle. So this is a high resistance waveform, and it has a sharp, narrow systolic peak. It comes back down to the baseline during end systole, and then during diastole it has minimal end diastolic flow. It has high pulsatility, or a large difference between the peak systolic and end diastolic velocities. Okay, now let's bring your eyes to the CCA, or the common carotid artery. So the CCA feeds both the ICA and the ECA. And remember that resistance is impedance to flow. So the CCA feeds the ICA and the ECA. So the CCA waveform ends up being a combination of the internal and external carotid artery. So let's just have a closer look at this. All right, so here's the carotid system on the left-hand side of the screen. The CCA feeding the ICA and ECA. ICA is larger caliber than the ECA, and of course the external carotid artery has extracranial branches, which the ICA does not. The ICA sits a little bit more posterior and lateral in the majority of the population, and the ECA tends to sit anterior and medial. Remember too that that first branch off of the ECA, right here, is the superior thyroid artery. The ICA receives 75% of its blood from the CCA. So 75% of the common carotid artery blood supply is heading up towards the brain, the internal carotid artery, remembering that it feeds the anterior and middle portion of the brain. So it is a low resistance waveform because it is feeding a low resistance arterial bed, our brain. Again, broader systolic peak, lots of end diastolic flow, lower pulsatility, and is monophasic. The ECA receives 25% of the blood supply from the CCA. And because our face doesn't need blood supply at all parts of the cardiac cycle and has higher resistance, or the blood has a tougher time getting there, it has a sharp systolic peak, and it has quite a brisk acceleration. It comes back down to the baseline and then has very minimal end diastolic flow. It has high pulsatility again, so a large difference between peak systolic and end diastolic velocities. Now the CCA is a combination of both a high and low resistive arterial bed, remembering 75% of the blood flow is heading towards the ICA. So it actually resembles both of these waveforms. If you note here, it has a sharp systolic upswing, and it has a broader systolic peak. So it's not as broad as the ICA, but it is a lot more broad than the ECA. The ECA has that really sharp, narrow systolic peak. It comes back towards the baseline. It doesn't touch the baseline and has quite a bit of end diastolic flow. So it has more end diastolic flow than the ECA, but it doesn't have as much end diastolic flow as this ICA does. So the CCA ends up being a combination of both the ICA and the ECA waveforms. It's feeding a high and a low resistant arterial bed, our brain and our face. All right, so now let's have a look lastly at the vertebral artery. The vertebral arteries, both the right and left vertebral artery, feed the posterior brain. So the cerebellum, occipital lobe, and brainstem are fed by the right and left vertebral arteries that join to form the basilar artery, and the posterior cerebral arteries come off of that. The vertebral arteries, again, have a low resistance waveform because they're feeding the brain. Our brain needs blood supply at all aspects of the cardiac cycle, and it needs a lot of blood supply during that time. Here we have a broader systolic peak, lots of end diastolic flow, low pulsatility, and is monophasic. The vertebral arteries actually have a slower velocity, so the red blood cells are traveling at a slower speed in comparison to the ICA. So that's how we'll be able to tell the difference between the internal carotid artery and vertebral artery waveforms once we move further into this course. So hopefully that helps explaining the common carotid artery, the resistance, the ICA, ECA, and visiting the vertebral arteries.